One moment.
Hello, it's Kale.
Hey, hi, Kale. We're about to begin.
Awesome.
Happy to see you here. Okay. Awesome. Excellent. We are going to officially begin. Hello, my name is Portia. Welcome to the IPFS weekly call, where we get to see all of the amazing things that are being built in the IPFS community. And we usually start off with announcements. It looks like we don't have any announcements for today, but if you are part of this call, if you could please put down your name in our notes, that would be great. So I just put in a Google Doc. Just put in your name, that'd be great. And so today we are going to hear from Kale Teeter from Microsoft. He's a senior software engineer, and he also works on blockchain. He spoke at TruffleCon. He has his own podcast. He talks a lot about the decentralized web. And today he's going to talk about IPFS in enterprise. So thank you.
Hey, guys.
Hey, so take it away.
Sure. So I'm going to share my screen here. Hopefully this all works okay. Let me try here. Okay. Just let me know, somebody, when you see it.
Yes, we see it.
Awesome. Okay, so does that cover up any of the slide there? Like, because I can see like our faces and stuff there, but you guys don't see that, right? Or should I hide that?
This view is fine.
Okay,
but
great.
I would just make the slides like, I would just have like ones. You didn't start the presentation yet, but I would just have like just the slide and not like the list of slides to the left. Yes.
Yeah, no worries. Great. So thanks for the introduction. Yes, I am a senior engineer. I work on the blockchain engineering team in Azure. Been for 3.5 years now, since shortly after Ethereum launched. We started working on use cases around enterprise, specifically around building consortiums, leveraging not just private chains, but also public chains. But we do focus primarily on building these consortiums with customers, large enterprises. And one of the things that's been coming up actually quite frequently, and we made an offering last year shortly after DEF CON, was IPFS for decentralized storage as part of the consortium. And so today I kind of want to talk about kind of what we built there, why we built it. And the pieces we built, to be honest, are really just wrapping what you all have kind of put together as part of the IPFS protocol and libp2p. And so just kind of want to walk through that and then tell you a little bit about where we see this going. I'll get some feedback from you guys and just give you some insight to that. So, when I talk about consortiums, I'm talking about essentially a network that's formed between, in this case, very simplified view, two participants or two companies. Essentially, when they're leveraging blockchain technology, they want to stand up a bunch of nodes, whether it be Ethereum, Corda, Hyperledger, any of the usual suspects there, and essentially run those nodes in a scalable, highly available way. And then basically have those networks all join very easily together, because it's quite complex to start building these networks. And so when we see that, what we spent a good part of 2016 and 2017 doing was automating that and making that something that's really easy for people to kind of spin up, invite people into the network, have them join in. And it's a work in progress. I mean, we continue, because this technology is so new, that we're continuing to kind of evolve network governance and how people join into those networks. And even to some extent now, I mentioned public, how these things are starting to branch into the public space, like public Ethereum, and things like that. From a decentralized ID perspective, there's also a lot of public work going on there. But one of the bigger ones, and I'll pick on Quorum here today, which is basically a fork of Ethereum that allows us to do things like private transactions. So essentially, we have our network running with Geth, just Go Ethereum client running. Then on top of that, we have a private transaction manager who's going to manage these private transactions. So essentially, participant one wants to do a private transaction with participant two. He uses these keys in this enclave of the private transaction manager to encrypt that, send that to him, and then when the block shows up in the blockchain, only participant two is allowed to basically decrypt and view that data. So that's typical. Companies like that. But if you look at what IPFS could bring to the ring there, and it's something we run into actually quite frequently, as I mentioned before, in a normal small use case, technically everything works, right? We have a smart contract written in Solidity that essentially has some state in it. But then we started branching out, and I think one of the first ones we kind of picked on was supply chain. And in supply chain management, there's bill of ladings, there's all kinds of other ancillary documents and data that's coming along with stuff that's going on in the supply chain. So we can certainly track, kind of the workflow of what's happening in supply chain, but then we had to basically store documents off chain. And so, the first, naive approach to that was, well, we can just, encrypt these files, put them in some storage, share them to other people. And when you have like two parties, yeah, it may work. But once you start getting beyond that into, maybe 15, 20, even beyond that participants, that doesn't scale. And so quickly the members are saying, like, how do we like the blockchain technology for the state management workflow kind of thing, but we don't like is the fact that we can't use our files like PDF files and things like that to come along with it. So how do we do that in a scalable way that makes it, that kind of fits with what we're doing here? And so initially, and I'll show you what we put in Azure to kind of use an experimental feature that IPFS has for basically creating private or permissioned versions of IPFS. And then they're allowed to essentially, as long as you're a member of that network, upload files to there. So basically, let me just jump out there and show you what we have. And feel free to jump in here, guys, if you have questions or if I'm going too fast or anything. So essentially, I'm in Azure here right now. We basically have a catalog here, and we have IPFS published up there. We published it on behalf of you guys right now. So we basically, and I'll show you the source code behind the scenes, what we did there. We're basically just wrapping the IPFS client in a Docker container and then doing some orchestration to spin it up. To end users, they come into the marketplace, like they come into Azure here, and they would just say, I want to create something new. And as part of that, they could type IPFS. And I have it in beta here right now just because some of the features we don't have fully lit up. I'll show you what those are in a second. But essentially, you can hit create here, and then it'll basically walk you through how big do you want the network to be, how many nodes, how fast you want it to be. And it'll essentially go build a bunch of IPFS nodes, make them private by flipping the flag in libp2p, and also building a swarm key and setting all that orchestration up. So basically automating all those pieces so you don't have to deal with it. Now I have one stood up here already, which essentially is just a couple nodes. I think for this demo, I just had two. So I have one in the East Coast right here, and then I have one in the UK. You can see a bunch of other stuff gets built around it. Most of this is just for the VM. So there's some IPs here. There's a virtual network that gets formed. These virtual networks, we have a feature in Azure that allows us to join them easily, peering. So if it comes up here in a second, I'll show you that. But essentially what it does is allows us to build a private tunnel using our dark fiber links between the data centers. So we're 10 gig a second, we can run through there. And basically you can build these peerings between them so that they can communicate just as they're on the same network. You can see these are connected right now. And then essentially we have our NIC cards. We have some load balancers here. The load balancers, essentially what I was doing there was if we form a network and I say, hey, I'm participant one, I want to have 5 nodes for some reason in my network just because I think there's going to be a lot of load or something. I can essentially put a internal load balancer in front of that. So anytime any of these others, let's say I'm working with somebody in the UK, my other participant in the network, they can communicate through that one, and it'll just spread it across our nodes in case one of them goes down or any of that kind of stuff. We have availability sets in here to protect the data. So basically they're durable VMs. That's pretty much it there. I mean, when they're stood up, it's pretty basic. Here's actually, if you look at the there's a Docker container running on this one. This is 2 nodes. So this guy's in the East Coast, this guy's in the UK.
Do you mind zooming in, please?
Sure. Let me see if I can just do this. I might need to jump out of Tmux to show that. Give me a second here. Maybe what I'll do is just kill this one. Just give me a sec here. Hopefully that's a little better. Yeah. So basically, we just have a Docker container. You can see it's running out of one of our private Docker repos. So this is part of our build process. I'll show you in a second how that works behind the scenes. But essentially, we have a Docker repository that's running in Azure. We call it the Azure Container Registry. And then essentially, it's spinning up these nodes. If you look at the logs for it, just to show you what it looks like when it boots up. Basically, it's going to essentially spin up, download all the bits for IPFS. It's basically then going to do this bootstrap. It's going to remove all the public nodes, and then it's going to generate a swarm key, and then it's going to go ahead and boot up using that key and basically restrict itself only to private on this interface. And this is running right now. So we have, if we did like, and primarily we just have people come through HTTP. So I'll just show you it locally here, but so you can see I have another peer here, which is the guy that's running in the UK right now. And here's his hash. So what happened out there whenever we spin these up is, and probably I should walk through and just show you what it looks like as you create a new network or if you're joining an existing one. What ends up happening is after the deployment happens, so you'll spin up a bunch of nodes here, you'll get some output that you can use to share with others. So one of the outputs is, once this comes up. So basically we have our boot node. So if we're spinning up a new network, this is what other people would talk to. We have our swarm key. And then if we had a VPN gateway, we would do that. So let me show you what that looks like a little bit. So if we're creating a new one, basically just tell it if we want to use, premium SSD or regular SSD or a hard drive for cost savings or any of that kind of stuff that you want to do. We pick our subscription we want to deploy it to. We can create a new resource group, which is just a container that the thing's going to run inside of. We pick the location we want the stuff to deploy to. Pretty much all of our Azure locations from Australia to Canada, pretty much worldwide. The networks where there's some interesting settings here. Once it loads up here. So essentially, here's our compute nodes. We limit it to 10 right now. And that's primarily just a function of how we have some of the templating done right now, but we could certainly lift that. We just haven't had a demand for more than 5 or 6 usually is the norm. You can basically pick the size of the VM, how much CPU and memory is there, and then you could say I want to spin up a new network or I want to join an existing one. So if you join an existing one, you'll pick a member ID, which essentially is just used for network governance. So if I spin up a new network and then I say, hey, I invite you to it, I'll say you are member number 2 or you are member number 3. They would pick that when they come in, and they would also add the swarm key and the boot node IP address that I gave them out of band. We're looking to automate that, and I'll talk about that in some of the next steps that we're looking to take with this. But for now, it's kind of an out-of-band process so that people have their networks protected. So basically, they just manually invite somebody to that. And then you can see here, you can actually spin up a full VPN tunnel if you want to do that, which is basically an IPsec tunnel. So essentially, if I'm saying, hey, I definitely want to connect other people to this, I would hit yes here. It would spin that up as part of the deployment. And then I would also share the pre-shared key there for people to join into that network once it's deployed. Cool. So let's jump back over here quickly. Looks like we're 15. So I wanted to talk a little bit about, that's some of the basics of just basically spinning up a private IPFS node on Azure in an automated form, joining a network, creating a new one. And that's kind of what I talked about as the first box here of decentralized shared storage. So now when people spin up their Quorum cluster or Hyperledger Fabric cluster or Corda cluster, and they say, I want to have some out-of-band storage for that, they can also come in here and use this template. And basically spin up that decentralized network, invite the other members that they want to join into that network as part of their whole blockchain solution. Now, some of the things that's quickly bubble up when you start doing this stuff is privacy and encryption is a big one that people, as well as key management, kind of goes along with that. And so what I mean by that is these files now, once we have this decentralized network stood up, they are available to anybody who has access to that. Anybody who would have access to those endpoints as part of the consortium. And there is possibilities that inside a network, let's say there's 10 people in the network, 10 different companies, maybe company one and company two are doing private transactions on Quorum. They also want to have private documents or private decentralized storage. And so what we're looking to do is actually, if I jump back to this slide quickly to show you, we're looking to essentially try to leverage the enclave that we have for Private Transaction Manager to also use that as the key for encrypting and decrypting the IPFS data. This way, the end users, when they set up their network, they don't have to maintain even another set of keys just to do this kind of encryption, decryption, or privacy of that. It could be transparent to them. This way, as they're doing their transaction in Quorum, it's automatically saying, oh, I got another file that goes with that. I'm going to use this key for encryption. When the receiving party gets it, he'll use his key from the enclave to decrypt it. Something we're working on with Quorum to see to make that real, because the reality is they need to be able to keep these at file level, basically security. The network invitation is still a little much out of band right now. So essentially, as people are onboarding into that network, it's very much like I have to contact you through email or something like that and say, hey, you want to join my network? I've stood up the decentralized network as part of it. That's something we have automated in other templates with email. So essentially it's the end of that template that I showed you, check a box to say invite so-and-so to this network, which would send them a formatted email that basically says go into Azure, or you could use other clouds if you want to. With Azure, it'd be automated and basically plug these parameters in there and you can join into this network. So that's something we're looking to kind of extend there to make it easier for people to use these. And to be honest, I think the longer term, cycle for this will be just as part of the template that we spin up Quorum with or Hyperledger or Corda or any of these other networks. We're just going to, I think we should add an optional section at the end of that just says, hey, while you're spinning up your blockchain network, go ahead and spin up some IPFS nodes. Just make it an optional component so they don't have to do two different deployments. They can just do it as part of one. So, I have some links here and things to the stuff I showed you here, and we continue to put sample code up here. We're going to be doing some hackathons here leading up to Ethereal, and we'd like to kind of build some more of this stuff around that as well to help people with specific industry vertical things like supply chain and showing the complete demo with, here's how I stood up my network with Quorum and here's how IPFS linked into that. And here's the whole flow so people don't get lost because there's a couple templates right now to spin that up. And then I have our user voice out there for anybody that has any feedback. And that's pretty much what we've been working on. So we put this out there. We've been getting some hits on it. So we have some telemetry coming back around people using it, and we've got a lot of interest from enterprise side saying this is what we need. Except for we also want that privacy aspect. So if you can add that on, it'd be great. So that's where we're at. I'd love to hear any questions, comments, or anything.
Awesome. Thank you very much, Gail. All right. It's time for questions. If you have any questions or comments, if you could put them in the chat, that would be great. And Gail, do you mind if you could stop sharing?
Sure.
Awesome. Thank you. Yay. I can see everyone's faces now. Okay. So Thank you very much for the presentation. And let us start with questions, and we will start with Johnny Crunch. Johnny Crunch, can you please tell us what is your question?
Yeah, so no surprise, I have lots of questions. One is, how do you verify the code that you've actually deployed it hasn't been altered? Number one. Two is actually, how are you integrating with the DID method spec for management of keys?
Sure. So on the code verification, so I didn't show you this, and I can, oh, actually, I'm not sharing now, but is it okay if I reshare here?
Yes.
So if you guys can see my screen, this is kind of like the internals, like how our templates are kind of built out. This is our Docker build over here, and basically the steps that go along with that. And then essentially, whenever it gets deployed, essentially on the VM, we run this bash script. So this installs Docker. We essentially lock the version in here. So we're locked to 4.17 right now. And then essentially when we pull those bits down, actually they're packaged as part of the Docker, that's right. So they get pulled into this. And we're just doing a wget here right now. So in our beta, we don't compare the MD5 hash or any kind of thing on that. So maybe that's something we should do in the future to guarantee the bits that we're pulling from IPFS are legitimate. And then essentially the swarm key that gets generated, I have a little application inside of here. It's a little node-based application that generates the swarm key. And then that swarm key is essentially only exposed on my network. If you go look at the template output, it's treated as like a quote unquote secret, which basically means it doesn't show up in any of our log files or any of that kind of stuff. So it's there, it exists as the network spinning up, and I can choose to share it with people. But as far as like from a privacy standpoint, we don't leave that hanging around or out there publicly exposed kind of thing. That's the first part, like how do we verify that the bits are good? And the second part, sorry, remind me.
Was DID method specs.
Yeah. So
you mentioned in passing.
Yeah, so there's been a lot of work, and specifically I've been working with both the consensus group, so Christian Roven and those guys from Uport, as well as Daniel Buckner on our side, who's part of the DID and the diff as a whole, and Occam is the other trio. I mean, there's others involved in the space, obviously, but those are the ones I've been mostly focused on. And the idea is we want to start leveraging that. We don't have this deployed publicly yet. But what we want to start doing is using those as the actors. So in Quorum right now, so like when participants are onboarding into the network, they essentially are tied to nodes. So there's a privacy transaction node. I want to kind of spin that a little bit because the problem is we're getting companies where there's a large amount of people in there, and we can't have we could have hundreds of keys over there tied to this enclave. But we're looking to kind of extend the DID spec for kind of role-based or group-based management. This way, as people are onboarding to like these IPFS node clusters or even the Quorum or Hyperledger networks or whatever, we can leverage that to say, hey, he's in accounting or he's in the warehouse, those kind of things. So whenever that person gets fired or moves on from the company, we don't have problems, coming back there. And essentially, the decoupling of the key mechanism as part of the DID spec is integral there, right? So we have an HSM inside Azure that we're using, Azure Key Vault, which supports the curves for Ethereum and those groups. And essentially, we want to leverage that as a backing store. But there's still some work to do there, to be honest, to make that whole thing join together, because we have some work to do on key recovery to make that work really well in an enterprise. But yeah, that's where we want to go, is basically get the keys that are in those enclaves that are signing transactions kind of decoupled from the user in such a way that we can recover them.
So I'm working on this right now. Do you have any documentation or a pointer to interfacing with the enclave?
With Quorum specifically, or is that
with Microsoft? And
Yeah, I can share the Azure Key Vault link for the stuff we've done there. And then also the work that we're doing with Tessera as part of Quorum is the first one that we were doing, but they're enclaves as well.
Yeah, and what about local to the device? If you're actually going to be, like, say, encrypting something and you actually want it to be decrypted with the hardware encryption built into a Microsoft device?
So we do have a beta out there of, I'm sure if you're part of the diff or any of the DID you've seen, we just released so basically the authenticator app that we had, which was like Authy. We basically are extending that. And so they put a beta out of that. So I'll send a link to that as well if you're interested to check it out. It's mostly for mobile. Use the enclave in the phone to also do the key storage and signing.
Cool. And just shameless self plug is I just put in the notes the DID, the IP ID, interplanetary identifier as DID method spec is up, and I would certainly welcome feedback. It's a draft, and I'm going to Barcelona at the end of the week to discuss it with the working group with W3C.
Awesome.
And all these links will be available in the show notes, and I'll also put them in the YouTube video once this video goes up. So we'll have all that stuff available. And next question from Dan. Dan would like to know, is the source code available for what you just presented to us today? So can we find the source code?
Yeah,
Awesome.
I'm happy to share the source for the template. To be honest, it's not really hidden. So when you deploy stuff in Azure, the last step right before you create it, it says download template and parameters. Most of the source is there, but I'm happy to share it. We don't have it in a public repo as of yet, but there's nothing secret there. So I'm happy to share it with the group. Ultimately, we want to make that open source, just get that out there, but it does take a little bit of work inside Microsoft for me to get all that stuff done. So we're just getting started here. But I'm happy to share it privately. So if anyone needs it, right now, I'm happy to share it with this group. I can just archive it and zip it up or something till we get it in a public repo.
Are there any other questions? Matt, are you seeing more push for encrypted content or non-encrypted content from enterprise?
Yeah, most of it's encrypted, right? Because most enterprises or companies that are working in the space, it's like a need-to-know basis for transaction details. And so they would much rather opt people into that than by default have it shown to everyone. That can vary some, but that's the general rule, is that people want to see that stuff encrypted, and basically on an as-needed basis, they allow people to see it, kind of thing.
Okay. We have time for one more question. Do we have another question? I have a question. Throughout the presentation, you did mention encryption, but I'm wondering, Kale, do you have a wish list of what kind of features you would like to see coming from IPFS?
That's a good question. Yeah, I mean, to be honest, it's been really easy working with the binaries and things, the builds that I've gotten out of you guys today. I guess the bigger question I would have is the feature I'm using there in libp2p, which is basically that flag to tell it to do private as well as so don't sync with public, is that's labeled experimental. I'm wondering what the roadmap is there for that. Is this something the Protocol Labs is looking to basically say we'll support this in the future? Because we're looking to drive this with big enterprise, and just wondering what the stance is from that on the private setting. I guess that's more of a libp2p question, but
do we have anyone who's working on libp2p that could answer that question on a call? If not, we can definitely follow up. Kel.
Okay. Yeah,
All
just
right,
like to make sure we're not deploying stuff out here that people go, why is this experimental?
Right. Well, that is it for our call. Kale, thank you very much for sharing your presentation, your time with us. And for everyone else, I will see you next week at the IPFS weekly call, and have a great week. Take care. Bye.
Thanks, guys.
Thank you, Kale.